We're done with discrete hypothesis, and now we're moving on to errors in discrete hypothesis. Okay, one thing that I need to say before we move on, the probability of type 1 error we've already calculated for the continuous, and if you remember for type 1 error, we used to just take the significance level as it is, and we used to say the significance level was 5%, we used to say probability of type 1 error is 0.05. If the significance level was 10%, we used to say the probability of type 1 error is 0.1. The reason was solely this, that in case of continuous, the probability of type 1 error, rather I should say, in continuous, the probability of the critical region is exactly the same as the significance level. Whatever is the significance level is the probability of the critical region or probability of the rejection region. But that is not the case with discrete. In discrete, whatever significance level that is given in the question is not the actual significance level. The one that will be mentioned in the question is the nominal significance level. The actual significance level is equal to the probability of the rejection region, which in turn is equal to the probability of type 1 error. So, at the end, the summary is this, that the probability of type 1 error would always be a little less than the significance level mentioned in the question. Because the area of the critical region in discrete is always a bit less than the significance level that is given in the question. Because see, for an area to be called a critical region, we need all the bars to be completely inside the range of the significance level. Let's say the range of the significance level is 10%. Now, let's say it's a left-hand test and the significance level is 10%. And let's say I find the probability of 0, 1, 2, 3, 4, all of them just to see till where I can go within 10%. Now let's say from 0 to 4, I am within 10%. The moment I add the fifth wala bar into it, I go above 10%. Which means that the fifth wala bar is not completely inside the rejection region. That means if the fifth bar is not completely inside the rejection region, it cannot be part of the rejection region. Because a bar to be part of a rejection region or for a random variable value to be part of the rejection region, its bar has to be completely inside the rejection region. Which means that our rejection region would start from 0 and end at 4. Now, if I'm ending the rejection region at 4, and if I find the probability from 0 to 4, I will notice that the probability from 0 to 4 is going to be a bit less than 10%. Because that's how I get all the bars completely inside. And by definition, the probability of type 1 error has to be the probability of the rejection region. It is not the probability, it is not equal to the significance level. It is only equal to the significance level in case of continuous hypothesis. Because in continuous hypothesis, the rejection region is absolutely equal to the significance level. In discrete, that is not the case. So by definition, we can't say that the probability of type 1 error is equal to the significance level, and nowhere we have said that. The probability of type 1 error by definition is equal to the probability of the rejection region. If the rejection region is equal to the significance level, then it's fine. Then I can take the significance level and just write as it is as a value for the probability of type 1 error. But if that is not the case, which is the case for discrete. In discrete, the probability of the rejection region will be always a bit less than the nominal significance level given in the question. Therefore, the probability of type 1 error will also be a bit less than the alpha value mentioned in the question. Are we clear till here? Okay. So as we do the question, I'm going to reiterate this concept, and with the diagram I'm going to show it to you. So all of this is already written here. So we're starting off with test and modeling for resolve. Okay, let's have a look at the next question. So I guess the null hypothesis, a single observation X is made in the test at a nominal significance level of 10%. Significance level is 10%. Carried out of whether the mean has decreased. To carry out whether the mean has decreased. If x is greater than 2, it is assumed that the mean is unchanged. So, what would be the probability of type 1 error? See, a mean random variable Poisson distribution, the mean is 6.5. So, the null hypothesis is that the mean lambda is 6.5. But, you made certain observations and you found out that the mean has decreased. So, that's what we tried to test, that the mean has gone less than 6.5. That's it. Now he's saying, if x is greater than 2, it is assumed that the mean is unchanged. That means if x is greater than 2, we accept h naught. Mean is unchanged means we are accepting h naught. Which means that x greater than 2 is the acceptance region. Then what is the rejection region? Less than equal to 2. Less than equal to 2 would then be the rejection region. So let's just make a rough sketch here, just to see what's happening. Okay, so 0, 1, 2, 3, 4, and so on. Now, apparently, x greater than 2, it is assumed that the mean is unchanged. Which means x greater than 2 is hinting at the fact that you need to accept h naught for x greater than 2. So, 3 and onwards is all acceptance region. Which means 0 to 2 is rejection region. They are asking find the probability of making a type 1 error. So I can't say the probability of type 1 error is 0.1. The probability of type 1 error is the probability of the rejection region. And when you find the probability from 0 to 2, you realize that it's going to be a bit less than 10%. So, part A, probability of type 1 would be probability of x, 0, 1 and 2. So let's find that out using the Poisson formula, e to the power minus lambda, and then this is the acceptance region, this is the critical region. Zero point 0.043 and
yes, that's the final
0.043 what?
0359.
4303.
0359.
Okay, so 430, which means it is approximately 4.3%, right? Which is less than 10%. So your probability of type 1 error is basically 0.0430. That's your probability of type 1 error. Okay, the question hasn't asked, but I'm just telling you. If the question says, what is the actual, the question may ask, what is the actual significance level? The actual significance level is 4.3%. If the question asks. The one that is given in the question is the nominal significance level. The actual is 4.3.
Significance levels.
Okay, equal is only because if you, okay, till 2 the probability is coming out to be 4.3%. You can do this if you take the probability of 3 and add it to this, you will realize that it goes above 10%. Which would mean that 10% is coming somewhere here. Somewhere in between. It is not completely taking the 3 in, it's not completely taking the 3 out. So 10% is somewhere here. Now, I cannot say that 3 is part of the rejection region because part of it is inside. For a bar to be completely, for a bar to represent a rejection region, it has to be completely inside the range of the 10%. Now the bars which are completely inside the range of the 10% are 0, 1 and 2. That's why only 0, 1 and 2 form the rejection region, whereas 3, 4 and onwards becomes the part of the acceptance region. Right? Because see, 3 is the number of events happening. If I take part inside and part outside, then I try to say, okay, so maybe 2.5 events or 2.9 events happen, then I'll reject it. If 3.1 events happen, that can't be possible. Either 3 events happen or 3 events don't happen. Either 2 happen or 3 happen or 4 happen. So for me to reject the null hypothesis on the basis of the 3 events have happened, the third event bar has to be inside the critical region, not partly. Are you good? Any questions? Okay, then I think the question is asking for the probability of type 2 error. And you know, whenever the probability of type 2 error is asked, they will always provide you with the actual mean value. Because type 2 error is all about accepting an actually wrong null hypothesis. So they are giving you the exact value. They are saying that the mean is not 6.5, the mean is actually 5.5. So on the basis of this new mean, can you find out the probability of the acceptance region? And that would give you the probability of the type 2 error. If you remember, what is probability of type 2? It is probability of the acceptance, but based on the actual value. So they've given you the actual value this time. It's 5.5. And we know the acceptance region is 3 onwards. So for part B, probability of type 2 is going to be probability of x greater than or equal to 3, but based on the actual mean value. And the lambda value that you will be using is 5.5. So based on this, we need to find 3 and onwards. Now you know there's no upper limit to the Poisson. So we will end up doing 1 minus x less than or equal to 2. You do the 1 minus?
0.9116. 911.
Okay, so this is approximately 91.2%. Very high probability of type 2. Okay. So the probability of type 2 is 0.913 basically. Don't get the probability in percentage, I'm just writing it out just like that, but get the probability in the decimal form, 0.912. Any questions? Given that the observed value of x was 4, so they did some experiment and they stand at 4. State the conclusion of the test and type of error that was made. If your x statistic is at 4, what are you actually doing? You are accepting the null hypothesis. Your x statistic is saying your x value is 4. So if it's 4, you're in the acceptance region. You're accepting H0. So for part C, accept H0. What type of error that was possibly made? You possibly stand a chance of making a type 2 error. Rather, you have made a type 2 error because आपने इसको accept कर लिया. आपको तो पहले ही पता है ये wrong है. He's already giving you the exact value. This is already wrong. But because our hypothesis was based on that, when our x value 4 came out, we tend to accept H0, and therefore we made a type 2 error. So So we made a type 2 error. Any questions? At the back, are we good? Shall we move on? Okay. Being modeled by a Poisson distribution meaning 1.5 per week. After a change in timing of the lights, there were 6 accidents during the next 8 weeks. Is this evidence at a 5% significant level of a reduction in the weekly mean number of accidents? So apparently H naught is 1.5 per week, but we think after the installation of the new traffic lights, so the lambda value has actually decreased. That's what we think. So alpha 5%. Your X statistic, by the way, is 6 with a new lambda value that you will be using is for 8 weeks. 1.5 times 8? 12. So with the lambda value 12. Okay, so it's a left-hand test clearly. And so on, right? Okay, so we start here. Now we need to check whether we are in the rejection region or are we in the acceptance region. So what do we do for that? We find the probability all the way from 0 to 6 and we check whether we are less than 5% or more than 5% clearly. Let's do this. Either you can do this or you can search for the critical region. Find the probability of 0, then add 1 to it, then add 2 to it, then add 3 to it, and keep checking. You are crossing 5% or you are staying within 5%. Once you identify the rejection region, then you can check whether you are inside or outside. That's the other approach. Whichever approach you want to take. Zero point 0458, which is less than 5%. 0.058 is less than 5%. So we are inside the rejection region. We are definitely inside the rejection region. Definitely the rejection region comes up till 6. We are inside the rejection region. We are just below 5%. So what do? We reject H naught. What type of error might have been made in this test? You might have made a type 1 error. Right? Any questions? Are you all good? So the answer to part B is they might have made a type 1 error. The number of times that the printing machine stops for attention during a given week has a Poisson distribution. Oh, sorry. Yeah. Has a Poisson distribution with mean 3.7. Machine undergoes some intensive adjustment and a two-take test is carried out based on the total number of stoppages X that occur over the 6 weeks. The test is on whether the mean number of stoppages per week has changed. So clearly, H naught is lambda equals and H1 is that the lambda has changed, so it's not equal to 3.7. It's a two-tailed test. The lambda that we will be using for calculations would be 3.7 times 6. I don't know how much that is. 22.3. 22.2. 22.2. That's the lambda that we will be using in the calculation. Alpha is 5%. Find in terms of X the rejection region of the test. So, how do we find the rejection region? The rejection region is on either sides. So, it means clearly that 2.5% is divided on both sides. What's the total number of trials? Oh, there are no total number of trials. Sorry. Yeah. So, can we find out the rejection region on the left first? So, 0, 1 and so on. So, let's add probability of 0, get the probability of 1 and so on, and keep adding them and see it should not go beyond 2.5%.
Sir, the lambda value is above 20, so
The lambda is about 20.
shouldn't we do it by a normal approximation or is this okay?
No, we should be normal also. Listen, can you just add and see what's coming out here? It is 18 by there are too many probabilities coming out in the normal approximation.
How can it compare what would have an
that what we do is, it's a long question. I'll have it with you after class. Just remind me. I think the probability is very low.
Yes.
Okay, so we use normal approximation. It was going to take too much time to go through that. What's the mean value? 22.2? It's 2.5%, that means 0.975. I think the Z critical is 1.96. Check. Is it 1.96?
Yes.
Okay. Okay, we need to convert the Z critical to the X critical because we need to give the rejection region. So let's convert the Z critical to the X critical. Minus 1.96 equals X critical minus 20 over root 1. Okay. Okay. By the way, the decimals over here matter or not. So give me the right answer. 12 point.
965.
Okay, 965 something. All right. Now we are forcefully using a normal approximation here because the lambda value is about 20. But now, just to find the rejection region, you need to again think of it in terms of bars. So originally these are all bars, right? There is a 0 bar, there is a 1, there is a 2 and so on. And apparently till here, you are getting 12.965. Okay. If you remember the concept, sorry?
So the 13th bar is outside.
It's, okay, I'll tell you. It's partly the 13th bar is also partly inside and partly outside. See, if you remember the concept of the continuity correction that we used to use, the whole idea was that there is, let's say, an 11 bar, there is a 12 bar, there is a 13 bar, and there is a 14 bar, let's say. Now, when we say 12.5, we are accommodating the entire 12 bar. When we say 13.5, we are accommodating the entire 13th bar. So, if, let's suppose, this rejection region includes the 12th bar completely, that means this value, this boundary value here has to be more than 12.5. Agreed? Now, if this rejection region has the 13th bar also within it, that means this boundary value include 13.5 also inside. This boundary value ends at 12.965. Definitely it has crossed the 12.5, it is somewhere here. So, till where do you have the bars completely inside? Till the 12th bar, so the rejection region is still 12. You have the 12th bar completely inside, the rejection region is still 12. Because the concept of the continuity correction that we go with, our 12th bar has to end at a mark of 12.5. Then after 12.5, the 13th bar's limit starts. So if this is giving you 12.9, so that means it's within the 13th bar. The 13th bar ends at 13. The limit of the 13th bar ends at 13.5. The limit of the 12th bar ends at 12.5. So if the boundary value is coming out to be 12.96, it's crossed the 12.5 bar. That means the 12th bar is completely inside. it's now about the 13th bar, which is partly inside and partly outside. And we know for a bar to represent a rejection region, the bar has to be completely inside. So the rejection region is actually till 12.
So if it was 12.4 something, so then we'll also exclude it.
Then 12 point, if it would have been 12.4, then we would have not taken the 12 bar. That means the complete 12.5, because the bar has to be, the boundary has to cross 12.5 for the 12th bar to be part of it. The boundary has to cross 13.5 for the 13th bar to be part of it. So it's like these are all bars, and the last bar which is inside is 12. So the rejection region from the left side is from 0 to 12. Are we good? Okay, now we need to state the rejection region from this point onwards. And your question will also be answered here. If your question was there is no upper limit to it, how to search for it? We need to know the boundary value over here as well. Can you somehow find the boundary value over here as well, just like using the calculation, right? And then I'll tell you how to figure that out. So 1.96, if I take 1.96 x critical minus 22.2 upon root of 22.2, my x critical comes out to be 31 point? Okay, 31.43 something. Alright. Now let's look at what is happening on the right side. Something like this is happening on the right side. Okay, so you have a 20. Okay. You have a 29th bar, then you have a 30th one, then a 31, then a 32, then a 33, and so on. Right? Where are you right now? Okay, let me just first let's notify the limits of each bar. 29.5, 30.5, 31.5, 32.5, and so on. You are 31.4. You are somewhere here. This is 31.5. This one is 30.5. You stand here at 31.43. Now see, the rejection region is this way. It's the right side of the rejection region. So if I look from here till 32, the rejection region is coming from the right side. Right? So till 32, I am within the limit. It's about the 31 bar that is not completely inside. Agreed? So I can't say the 31 bar is part of the rejection region. My rejection region ends at the 32 bar. So that means on the right side the rejection region is 32 and onwards. There is no upper limit to the Poisson. It's 32 and onwards. 32 and onwards for me is a rejection region on the right side. So now we can state the critical region. The critical region is x to be from 0 till 12, or x is from, or x is greater than or equal to 32. This is your critical region. I hope it's making sense. Are you good? Any questions? Abdul Hafiz, Abdul Moiz, Abu Bakr, Adil Latif, Aisha Mushtaq, Ali Yusuf,
Sir.
Ali Shahriaz, Ali Aslam, Dania Ashraf, Fahad Arif,
Sir.
Adika Hussain, Hina Amar, Uzaifa Ahmed, Maliya Zani, Ali Umrani, Numan Pracha, Fahad Abid,
Sir.
Moin Khan, Umar Athar, Usman Shoaib,
Present.
Mohammad Yusuf,
Sir.
Murtaza Mustafa, Murtaza Rana, Nida Asim, Pranav,
Present.
Ramsha, Rimsha, Ruhan Nadeem,
Present.
Safa Ahmed, Aman, Sehrayaz, Sherian, Shehbaz, Shifa, Nasad,
Present.
Maha, Taha,
Here.
Taj, Zaid,
Here.
Zainab. Thank you. अपने लिमिट हो ही इसमें पता है क्या प्रॉपर्टी से होगा ये जीरो सिग्निफिकेंस है इसके सर्टेन पॉइंट के साथ जब इसे